The number of moves needed for additional rings in the solvent suggests a pattern that approximates repeated multiplication. An exponential function is a function with the general form y equals ab raised to the x power, where a does not equal 0, with b greater than 0, and b cannot equal 1. The general form of an exponential function. Again, y equals ab to the x power. A is non-zero, b, the base, is a constant, b is greater than 0, and b cannot equal 1. The exponent x is the independent variable, with the domain being the set of all real numbers. Problem 1. Graphing an exponential function. What is the graph of y equals 2 raised to the x power? Well, step 1. Make a table of values. On the far left column are inputs x, -4, -3, -2, -1. The next column, 2 raised to the x power, well, that'll be 2 to the -4th, 2 to the -3rd, and so on. The column to the right are y values associated with the inputs x. First, 1/16 in decimal form as 0.0625, followed by 1/8, also shown in decimal form, 1/4, and 1/2. And a second table to show some positive values and make sure we get a clear picture of the behavior of this graph for both negative x values, 0, and positive x values. X is of 0, 1, 2, and 3. A middle column, 2 raised to those x values. And on the right-hand side, y values as outputs of the function. In step 2, we'll plot and connect the points. So -4 and 0.0625, -3 and 0.125, and so on up until the point 3, 8. Your turn. What is the graph of each function? Part A, y equals 4 to the x power. Part B, y equals 1/3 to the x power. And part C, y equals 2 times 3 to the x power. And part D, a reasoning item. What generalizations can you make about the domain, range, and y-intercepts of these functions?